Data storage, it's important. And a lot of photographers, including me, seem to forget about this. So I've decided to remedy this problem for myself by building 2 brand new NAS units. One to replace my Linux ISO server and one to be a brand new archiving backup NAS for all of the crap photos and videos I take. So let's get started. So the general plan for all this storage is for me to have 2 NASs, one for my Linux ISOs and the other one as a production NAS, which will just be a massive pool of data that I'm going to use to archive old photos, video projects, YouTube stuff and all that. And the reason I'm building this now is because my desktop computer has an 18 terabyte hard drive in it, which is a massive single point of failure, and it's also full. Now when it comes to my YouTube videos, I do actually keep all of the original raw footage, but I use DaVinci Resolve's media management tool, which actually trims the video down to the pieces that you've used. So that saves a lot of space. You know, it might turn a 300 gigabyte project down to 50 gigabytes. But that's still 50 gigabytes, and you do 20 projects, that's a terabyte. A couple of big projects, like some of the travel videos I do, those can reach 2-3 terabytes in size. And all of a sudden your 18 terabyte hard drive fills up in 2 years. So I'm going to try and alleviate this problem by building a massive new 5-bay NAS. I'm using these Johnsbo N1 NAS cases. The hard drives I've went with are these Seagate Xenos, whatever they're called, 16 terabyte drives. I have 5 of these, which will give me a total capacity raw of about 80 terabytes. And then once you account for redundancy where one drive is used for parity data, you're talking 50 to 55 terabytes worth of actual usable space. So that should keep me going for a couple of years at least. Now this server is actually quite old. I recently transplanted it into this very nice Johnsbo N4 NAS case, and the reason I use this case is because it's an M-ATX motherboard. But the problem with this NAS is that it's actually quite power hungry. So this is using a desktop CPU, it's an Intel Celeron something or other, it's like 8 years old now. It requires a lot of power to run it. In comparison, the new motherboards that I have for these have inbuilt laptop CPUs, which is designed for power efficiency because they're normally designed to, you know, run off of batteries. It means you can use them to make very low power server hardware for this exact use case of network attached storage. So the first thing I suppose is we'll get stuck into building. Time to build a NAS 2. Electric Boogaloo. Okay, so status update. First, this little Ninja Inferno screen is a portable HDMI monitor. Very good. Second status, you might notice that there is computers everywhere. Both servers are having problems. This one is refusing to boot Unraid for some reason. I don't know why, it just is. It's just like, yeah, I'm not going to boot that. No, what's really frustrating me now is this box here for TrueNAS, because one of my hard drives isn't showing up and I don't know which one. Computers, so much fun. So, summary of the situation right now. Das ist nicht gut. To put it mildly, my fancy new high capacity NAS is on hold for a few days because one of the drives arrived dead. That's the very first time this has ever happened to me. I've never had a broken drive arrive, and that's really frustrating that it's happened now. But essentially, the drive was beeping at me. I thought it was the PC speaker beeping. I thought, oh, maybe there's some like weird hardware issue or a setting or something I need to do. I'll figure it out later. No, it turns out that the drive itself is beeping. And on a Seagate drive, if it's beeping, it means it is shagged. Pro tip, by the way, if you're in like TrueNAS and you want to figure out which drive is dead, it turns out that the drives are listed with their serial number, which is on the top. So you can actually just read the serial number straight there and see which drive isn't working. Okay, remove my install media, fire up. Hopefully it should boot up now, nice and easy. I've been having trouble with this motherboard. It's very finicky. You have to like use UEFI and a bunch of other things. It has to be absolutely spot on or it just won't boot. Hey, TrueNAS, she's booting. Okay. So after like close to 2 days work, because of all the hassle and the stupid dead drive problem and the config and the timing of everything and all the other shit I need to do, it's actually finally working. I need to wrap that up and get ready to ship that back to Amazon. Slides over all the cables nicely. Nothing's getting caught anywhere apart from that SATA connector. That really should be strapped in. Oh well. Okay, let's go over to the wall and get this plugged in, or over to the shelf. She's sitting here nicely. One of the reasons I wanted it to be quiet is because it's right next to the couch. Apart from that though. Where's the cover? Hard drive for shipment. Cables. So long last, the NAS is up and running. My replacement hard drive arrived today, which is really nice. So I've got that in the system, tested everything. It all looks good. I also have the NAS set up as a static IP on my local network, so I'm able to access the remote interface, which is all here and set up nicely. So in order to actually access the data, we have to first set up how the drives are going to be used and configure it in data pools and storage. Then we need to take that and make it into a share. So in order to set this all up, the first thing we need to do is create a pool of drives, and then we're going to create a data set on top of that pool, and then we're going to create a share which will share a folder within that data set. And then the share is the actual thing that we can access from other computers on the network. So let's set things up. First thing we're going to do is we're going to go to storage. We need to create a pool. This is going to be called archive. Next up for our data, this is our VDEV, or just how we're going to combine the drives together. Now for 5 drives, the best option is RAID Z1. So RAID Z1 is a parity system. And what will happen is the data will be written to 4 drives, and then one of the drives is reserved as the parity drive. So that way, if one of the drives dies, you can use the parity drive and the rest of the data to rebuild that drive and get all your data back. This is the kind of reason you run RAID in the first place. So we have 5 of our 16 terabyte drives are here. They're showing up as 14.55 TB. We're going to make a 5 wide array of drives with RAID Z1, so 1 drive of redundancy. So that means our total accessible storage capacity will be, it actually says it here, raw capacity will be about 58 terabytes, which is a good amount. Log, optional, we're not going to do anything there. Spare, nope. Cache, nope. Metadata, nope. D-up, nope. Review. 1 pool, 5, 15 terabytes, RAID Z1, usable raw capacity, 58 terabytes, create pool. Yep, once you create the pool, all the data on the disks is gone. So if you have data on those disks, you're reusing from something, make sure you back everything up. Anyway, next thing we need to do is set up credentials, and we're going to create a user. So this is the admin user. We don't want to touch that. So we're going to add a user, Patrick, which will be me, password, email, don't need to set anything, var empty, create new primary group, blah, 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 read, write, execute, yep, save. Okay, so the reason we're creating a user is this will be the user that will be used to access the storage over the network. You can technically do it as like root user, but it's really bad idea. So we're creating a user which will have access to the drives, but won't have access to any of the admin stuff, so that we can access the data, but nothing fancy. We have to log into the web console and use the root user that way, which is the admin. Although technically there is actually a root user, there's an admin user. You never use the root user, you use the admin. Security. Okay, data sets. Let's create a data set. Parent path archive, name, archive, generic. We're going to be setting this with SMB. Yep. We're not going to create SMB. Yeah, we'll create SMB share archive. Advanced options. Let's see, compression level LZ4. This is kind of nice. It transparently compresses data on the disk, so you might save 2, 4, 5% of data. For video and photo, you're not going to save much, but for like a lot of text files and like database stuff and things like that, you can actually save a lot of space. Okay, save. Let's create our data set. Done. No, we're not going to start that yet. We're going to go to our shares. We're going to edit the access control. Who, user, Patrick allowed. So this is basically, everyone allows us to access, everyone to access it. We don't want that. We want to set user Patrick, permission full, type allowed. You can change this to like read write, so you can give like people read access but not write access. So I'm just going to create that. Turn on service. Okay, running. Okay, so here we are on my current machine. This is my 18 terabyte drive, which is very full. Media, that's my Linux ISO NAS. So we're just going to map a network drive. / 192.168.0.50 archive. Finish. Remember my credentials. Okay, so here we have our archive. So let's pull some public videos. Let's create some folders here. You can see here I'm using O2. That keeps the order of the files in the same way. Trust me on this, it's worth setting up like that. Just having O1, O2, O3, and then your folder name allows you to keep everything in order. So this is all like random crap. Let's copy the audio folder over. So it is archiving all my audio files. So for file transfer speeds, everything seems to be running pretty good. We're getting about 200, 250 megabits a second, which is what my network caps out at. It's currently a 2.5 gig network. I am upgrading it to 10 gig very soon. I have all the ports I need. I just need to rebuild my computer to have a 10 gigabit NIC because there's no PCI slots left. And then I have to also get the transceivers to Ethernet to, because they're all SFP ports, so I'm just going to hook them up, and I have an SFP 10 gig card coming for the NAS that I'll have to set up as well. It's going to be a whole thing. Anyway, that's it for setting up my beautiful new home NAS. Now I actually have somewhere to store my data that actually has some redundancy and a little bit of safety rather than just a single giant drive on my desktop. And now I'm faced with many, many hours, possibly days, of copying over a lot of this data into my archive NAS. And with that, I'll see you next time. An inch longer, just 1 inch, and I'm getting a call. In case you're wondering, yes, that is the Pokemon theme and also the Dancing Toothless meme. Oh boy. Guess whose delivery driver got lost? Well, yeah, food's here. I'm gonna go eat. I'm hungry.